Okay, so imagine a treasure hunt, but instead of a little chest of gold, you're looking for an entire world made of metal. The prize? It's almost impossible to wrap your head around, and it's just floating out there, right in our own solar system. Let's dive into what could be a new cosmic gold rush.
Just look at this number for a second. That's $10 quintillion. A 10 with 18 zeros after it. To give you some perspective, the entire world economy is worth around $100 trillion. This number right here is 100,000 times bigger. It's so huge it could, in theory, fix every single resource problem on Earth. Or, completely shatter our economy if it all showed up at once.
So what on Earth, or maybe what off of Earth, could possibly be worth that much money? Is it some fleet of alien ships? The value of a whole new galaxy? Well, the answer is actually a lot closer to home, but still incredibly far away.
That's right, $10 quintillion. That is the estimated price tag for all the iron, nickel, and precious metals locked away inside one single object in our solar system, an asteroid named 16 Psyche.
So let's get to know our main character here, 16 Psyche. It's what's called an M-type asteroid, which is just a fancy way of saying it's super rich in metal. And it's just hanging out, orbiting the sun in the main asteroid belt, that big stretch of rock and debris between Mars and Jupiter. Now, it might be tiny compared to our moon, but don't get me wrong, Psyche is no little space pebble. It's about 227 kilometers across. To give you an idea, if you could just plop it down on Earth, it'd cover an area about the size of Massachusetts. It's actually so massive that its gravity messes with the orbits of other asteroids nearby.
When you find an object this unique, this valuable, it's pretty obvious it's going to be a prime target for a closer look. And that is exactly why NASA sent a robotic explorer on a journey of billions of miles just to solve its mysteries.
And let me tell you, this journey is a long one. The Psyche spacecraft took off back in October 2023, and it's speeding through space as we speak. In 2026, it's going to do a flyby of Mars, basically using the planet's gravity as a slingshot to fling itself deeper into space. It's not even scheduled to get to the asteroid until August of 2029. And once it's there, it'll spend more than 2 years mapping and studying this metal world like never before.
So why? Why is Psyche so packed with metal? Why isn't it just another chunk of rock and ice like most of the asteroids out there? Well, the answer might actually be hidden in a really violent, ancient chapter of our solar system's history.
So to really get Psyche, you first have to know what a protoplanet is. Billions of years ago, our solar system was just this chaotic mess of dust and gas. And these small bodies called protoplanets, kind of like the seeds of future worlds, started clumping together. Okay, so the leading theory goes something like this. Psyche is actually the leftover core of one of those ancient protoplanets. As this baby planet was growing, all the heavy stuff like iron and nickel sank to the middle, forming a metal core. All the lighter rocky stuff floated to the outside. But then, bam, disaster. A series of massive hit-and-run collisions with other big objects literally blasted away its rocky crust and mantle, leaving just the stripped, metallic heart behind. So Psyche is, pretty much, the exposed core of a failed planet.
But here's where it gets really interesting. Despite its reputation, Psyche probably isn't a solid ball of metal. Recent data suggest it's more of a mix, with metal making up somewhere between 30 and 60%. The rest? Probably low iron rocky material, maybe with some carbon-rich dust sprinkled on top from later, smaller asteroid hits. Figuring out that exact recipe is one of the main reasons we sent a probe all the way out there.
The scientific value of Psyche is huge, right? It's a chance to peek at the heart of a planet, something we could never do otherwise. But let's be real. That $10 quintillion number points to a much, much different motivation. The start of a whole new cosmic gold rush.
I mean, the reason we're even looking to the stars for this stuff is pretty simple. We're running out of key resources right here at home. Studies show that the reserves we know about are getting used up, and fast. We've already gone through over 90% of our mercury, and about 3/4 of all our silver and gold. This scarcity is what's pushing us to look for new frontiers.
And this table really shows you the incredible contrast. Think about cobalt. It's essential for EV batteries. 70% of our supply comes from the Democratic Republic of Congo, which is geopolitically risky, to say the least. Asteroids could have vast, completely untapped reserves. Or platinum, which is vital for electronics. It's super rare on Earth, but a single asteroid could hold billions of dollars worth. Space offers an economy of abundance, which is the exact opposite of what we're facing down here. Okay, so dreaming about all these cosmic riches is one thing, but actually getting them, that's a whole other ballgame. How would you even mine an asteroid that's floating in a vacuum? Well, it's going to take a whole new generation of seriously futuristic tech.
So here's the fundamental problem. On an object with almost zero gravity, the second a traditional drill even touches the surface, it would just push the entire spaceship away, sending it spinning off into space. You can't just dig. So engineers have to completely rethink the whole process.
And this is where innovation gets really wild. Companies are working on some truly mind-blowing solutions. You've got ideas for swarms of six-legged robots that could crawl across the surface and anchor themselves down before they start digging. Other ideas are even more sci-fi, like optical mining, where you'd use giant mirrors to focus sunlight into a beam so powerful it literally vaporizes the rock to release the metals which you can then collect. And maybe the weirdest of all, biomining, using special microbes that can actually eat the rock and process it for us, spitting out the valuable metals we want.
A future full of robotic miners and space-forged steel is, well, it's an exciting vision. But we have to be realistic here. This isn't going to happen tomorrow. The road to a space-based economy is filled with enormous challenges.
And for a quick dose of that reality, look at what happened with the Odin mission. In 2025, a private company called Asteroid launched the very first commercial probe meant to visit an asteroid. Just a few days after launch, it went silent. Total radio silence. Deep space is an incredibly harsh and unforgiving place, and even our very best tech can fail.
And the hurdles are just monumental. A single mission costs billions of dollars. The technology is still brand new. And then there's a huge legal black hole. Who actually owns an asteroid? The Outer Space Treaty from 1967 says no country can claim a celestial body, but it's really vague about private companies pulling resources out of one. It's the cosmic Wild West. And finally, there's the big paradox. What happens if you actually succeed? If you bring all the metal from Psyche back to Earth, you would instantly crash the global commodities market. The prize is so big, it would destroy the very concept of its own value.
So, if bringing all these metals back to Earth is so full of problems, what's the real long-term prize here? Well, the ultimate vision isn't really about making Earth rich. It's about building a whole new economy beyond Earth.
The key idea here is called in-situ resource utilization, or ISRU. It's a simple idea, but it's revolutionary. Just live off the land. Instead of launching every single thing we need from Earth, which is incredibly expensive, we use the resources we find in space to build what we need right where we are.
And this is where the vision gets really big. See, asteroids aren't just full of metal. A lot of them are packed with water ice. You can take that water, split it into hydrogen and oxygen, and boom, you have rocket fuel. Asteroids become our cosmic gas stations. The metals can be 3D printed into habitats, tools, even new spacecraft. This is the absolute critical step to building self-sustaining bases on the Moon and one day, even cities on Mars.
So this all brings us to the final, huge question. The pull of the asteroids puts humanity at a major crossroads. On one hand, it's a potential solution to our resource problems and a stepping stone to becoming a species that lives on multiple planets. But on the other, it carries huge risks of failure, economic chaos, and maybe even extending our earthly fights out into the cosmos. The ultimate prize might not be the gold in the rock, but finding the wisdom to use it right.